Good evening, everyone. This is Vikas Srivastav again, founder and CTO at AlmaBetter. I welcome you all again on behalf of Team AlmaBetter to the fourth day of week one, module one of our data science LER program. And today we'll be talking about some other fundamental objects in Python, such as tuples, sets, and dictionaries. So yesterday we talked about list objects in Python. So this session is being watched by students of our cohort Arauli, people who have joined through the AlmaBetter platform, and there are other people who have joined us through the live streaming portal. So I welcome you all again in this session. So before we start with today's lecture, let's go through the assignment which was rolled out yesterday and try to look at the solutions. So so basically today we'll be talking about what is a tuple, then what are some tuple functions and methods, what is a set and what are some common set operations, what is a dictionary object, and what are some functions and methods associated with these dictionary objects. So we'll be talking these things and learning these things today. So but before we go ahead, and I'll just go through the assignment solution of yesterday's. Okay. So yesterday you were given some questions on list objects. So the first question was, a list contains the average daily temperature of a city over a particular week. So there were seven set of temperature values which were given in a list object. Then you were supposed to write a Python code to swap the highest and the lowest temperatures. So I'll explain what this question means. So you were given this list, okay, which contains 7 temperature values. Okay, so the highest temperature is 42 and the lowest is 21. You are asked to swap these two values. So the expected output temperature list will be this one. So in which the lowest and the highest temperature values have been swapped. Okay, so how do we go about solving this particular question? So first we need to do some basic steps. So first we need to store the maximum temperature value from this list. So we can call the max function. You remember this from yesterday. So max function calculates the maximum of these values from this list temperature. So it stores the maximum value. Then we can find out the index of the maximum value. So in this case, this is 42. So we can find out the index of this maximum value by calling the index method. And within the argument, we provide the value of the maximum temperature, which we have gotten from here, right? So this will return the index of the element, okay, which is the maximum temperature in this particular list. Okay. Similarly, we do the same thing, but this time we are not taking the maximum, we are taking the minimum. Okay. So we store the minimum temperature in this particular variable min temp, and then we store the index of this element min temp with the in the index variable min temp index. Okay, so these two steps are more or less similar. Here we are just taking the maximum and here we are taking the minimum. Okay, now we need to swap them. So how you can swap them? So basically you remember that list objects are mutable, right? So you can assign a particular index any value which you want to assign. So the element which sits at the maximum temperature index, you will assign that value with a minimum temperature, right? And the index which corresponds to the minimum temperature, you will assign that the maximum temperature value. Okay, and once you do this step, so basically you can go ahead and print out the temperatures, and you can see that the maximum minimum temperature have been swapped here, right? So so basically, so this is our output temperature which we wanted to know. So as you can see, earlier we had 29 and 42. Now we have 42 and 29. Okay, so this was pretty straightforward. Okay, now moving ahead to the next question. So next question was a bit interesting question. So here you are given two measures of averages. I think you already know about these terms. So one is mean. So what is a mean? A mean is defined as the sum of the elements in a group divided by the number of elements in that group. Okay, then again, median is defined as the middle number in a sorted ascending or descending list of numbers. So a list can have n numbers. Okay, so depending upon whether n is odd or even, the median will have different formulas. So if the median has n elements where n is odd, the element in the middle will be n plus 1 by 2th element. Okay. So, and if the number of elements in your list is even, okay, so the median will be the mean of n by 2th and n by 2 plus 1th element. Okay, so basically the sum of these two elements divided by 2. So what do I mean by this? So I'll just cite you a basic example. So here we have the list of product prices. Okay, so how many elements are there? So basically I'll first connect this. Okay, so yeah, so we can see that here we have 10 elements. Okay, so 10 is an even number. So we'll see how we can calculate the median. So but the first step is to calculate the mean price. Okay, so what is the mean price? So you take the sum of all the elements in your list and divide by the number of elements. So how do you get the number of elements? Simply call the length function. Okay, and in the parenthesis you provide the list object here. Okay, so yeah, I'll just run this for clarity. Okay, and yeah, so I'll just print this mean price. Okay, now the next step is basically calculate the median. Okay, so what is the first step? So first step is you need to sort it either in ascending or descending fashion. So we'll basically take the ascending way. Okay, so I calculate or store the sorted list in another list object which is defined as sorted prices, and I call the sorted function, and in the parenthesis I provide my original list. So this will return the sorted prices. So I can just go ahead and run this one. Okay, so these prices are now sorted in ascending fashion. Okay, now you can calculate the length of this list, which is indeed the same as the original one. We just have sorted this one. Okay, now using the corresponding formula, depending upon whether n is even or odd, we can calculate the median price. Okay, so what is n here? So the length is 10, so this is even, so we need to use this particular formula. Okay, so what is the n by 2th element? So the n by 2th element, so n is essentially length of sorted prices, right? So n by 2th element is basically a length of sorted prices by 2. But because indexing in Python starts from 0, so the index of that n by 2th element will be the integer of this one, that is length upon list length divided by 2 minus 1. So this will return the index corresponding to the n by 2th element. Okay, so you basically take this element. Now next what you do, you take the element, okay, this particular element n by 2 plus 1. Okay, so this is sitting at the index list of length by 2. We are applying int function here just to convert that operation into an integer, because an index will always be an integer. Okay, so this operation will return a float value, so we need to convert this into an integer. Okay, and basically yeah, so we sum up these two elements and divide by 2. So this gives us the median price, which is 575, and I'll tell you why is that the case. So basically consider this particular list. Okay, so these are the first 4 elements and these are the last 4 elements, right? So the 2 elements in the middle are 550 and 600. So the mean of these 2 elements is your median. So what is the median of these two? The basically these sum of these 2 elements divided by 2, which is 575. Okay, so keep this in mind that this will be minus 1. Okay, because we need to provide the index here rather than the element, basically the position of the element. Okay, so essentially index corresponds to the position, but this will be subtracted by 1. Okay, because indexing in Python or list starts from 0, right? And again we were basically we had to check whether the mean price was greater than the median price. So yes, the mean price was 1975 and the median price was 575. So basically you were also asked to give an explanation of why do you think that is the case. So this is the case because in our, as you can see in our list, these 9 value, they are almost of the same range. Okay, these are means orders of magnitude is around basically of 100 or basically between 100 and 1000, right? but this last value is 15,000, which is very large, which is much larger than the rest of the elements, right? So the mean gets skewed by presence of any such large numbers, okay, but the median does not. Okay, so that's why we'll see later when we're discussing statistics that whenever we want to remove the effect of any outlier, basically any number with a very extreme values, we should use median rather than mean. Okay, so the median here is not affected by presence of any such element with very much larger value as compared to the rest of the elements. Okay, so that is the case. The third question was basically you're given a nested list, okay, and what happened, what was the scenario? So an individual was asked to collect the names of companies in the technology sector, okay. So what happened then, while creating the list, by mistake the last three companies were subsumed in a list as shown below, okay. So you are required to just get rid of the nesting. So what was the issue? So when the guy was creating the list of companies in the technology sector, so basically the last three elements, it got subsumed in another list, okay. So you remember from yesterday that basically you can have nested list, means basically a list object can be an element of another parent list, right? So this is what a nested list is, and you need to get rid of the square brackets. So the expected output was basically get rid of the square brackets, and you needed to have all these 6 elements here, okay. So just needed to get rid of the square bracket. So how do you do that? So basically you're asked to solve this problem using two different approaches, okay. So the first approach is very easy. So you can basically extract the last element and store in this variable last element. So how do you extract the last element? By calling the index value -1, which corresponds to the last element, okay. And what you can do, basically you can take a slice of the list till the second last element, which with this slice, okay. So basically you're asking Python to take grab all the elements but not the last one, okay. So it will grab all the elements till the second last, okay, and you just add the last element, okay. So basically when you add the last element, so we can go ahead and print this one, okay. So yeah, so now we have the exact list which we wanted, okay. We can do another thing. So basically here I'm not creating another new variable, but we can basically transform this original list itself, because remember when we are calling any method on a list object, that will change the list, okay. So what I'm doing here, I am basically, because I've already stored the last element in this particular uh, object, that is the list element here, okay. And okay, so basically yeah, you can remove the last element once we have stored this here, and now you can extend this list by basically adding the last element here, okay. So you can, yeah, you'll get the same result using this method as well, okay. So these were the problems which we were given yesterday, and these were, yeah, slightly straightforward, okay. And people who got it perfectly, kudos to you, you did really well, okay. So now, yeah, moving ahead to the contents of today's session. So basically we saw that we have encountered objects such as strings, okay. And yesterday we talked a lot about list. So strings and list are sort of sequences in Python, okay. So if you want to get any element within a list or a string, we need the concept of an index, which refers to the location of a particular element in those objects, right? So another continuation of list is a tuple, okay. So let us see what are tuples. So in Python, tuples are very similar to lists. However, unlike list, they are immutable, meaning they cannot be changed. So we saw that you can basically change a list object by calling in some methods, right? So you can basically call a remove method or a pop method, and that will transform your list. That means the lists are mutable. They are vulnerable to changes, right? And but the important distinction between a list and a tuple is that tuples are immutable. Okay, tuples object cannot be changed, similar to strings. Okay, so we'll see the manifestation of this particular property. Okay, so when do we want to use tuples? So we would want to use tuples to present things that shouldn't be changed, such as days of the week or dates on a calendar. But it has a lot of scope in terms of programming in Python. For example, when we talk about functions later on, so we want to sometimes return a set of values, and we'd basically use tuples to return those set of values. Okay, so we'll see about the utility of tuples later on. Okay, so you'll have an intuition of how to use tuples based on what you have learned about list. Okay, so we can treat tuples very similar to the list, with the major distinction being that tuples are immutable. So the very important distinction or very important difference between a list object or a tuple object is that tuples object are immutable. A list object is mutable. Okay, so you understand the term for mutable. You understand the term mutability, right? Okay, so how do we create or construct a tuple? So basically, the construction of a tuple use the parenthesis with elements separated by commas. Okay, so suppose I need to create a tuple. So in the list, we had to provide the square brackets, but in the case of tuple, we need to provide the small brackets or the parenthesis. Okay, and here also the elements of the tuple will be separated by comma, and these elements can be of different data types as well, which is what we saw in the list as well yesterday. Okay, so how do you define a tuple? So basically, you define all the elements in a tuple within the parentheses, and these elements will be separated by commas. Okay, so I'll just go ahead and I'll first just connect this. Okay, so yes, so it's very similar to list, just instead of the square brackets we have the parenthesis here, right? And again the elements will be separated by commas. Okay, so I'll just go ahead and execute this particular cell. So now I've created my tuple. Let's go ahead and print this tuple. So again, so you can see this is the tuple which has the first element 1, the second element is a string which is 8, and the third element is 3, right? We can also mix object types as we saw earlier here, right? So we can not only have elements with similar data types, but we can have elements with different data types, right? So I'll just so this is another tuple example, and we can basically get the type of this variable by calling the type function. So I'll just run this, and this is a tuple. So Python understands that anything which is enclosed in square parenthesis and the elements are separated by comma, so this will be a tuple. Okay, when we call the type function in a list object, we got the output list. So similarly, this is a type, this is of type tuple. Okay, so now okay, now we want to talk about tuple indexing. So this is similar to a list. Okay, so indexing works just like in lists. Okay, a tuple index refers to the location of an element in a tuple, very similar to what it does in a list. Okay, and also remember a very important point: the indexing begins from 0 in Python. The first element is assigned an index 0, the second element is assigned an index of 1, and so on and so forth, right? So if I want to grab the first element of my tuple, so I can simply write my tuple object, and within the square brackets I can provide the index. Okay, so this square bracket is sort of common across strings, across lists, across tuples, right? So if you want to get a particular element, or you want to take a slice of these objects, so you need to provide the square brackets, and within these square brackets either you specify a single index, or you can specify the starting and ending index with the colon positioned in middle. Okay, so we can just go ahead and run this one. So the first element of our tuple is 1. So so this is our tuple. So first element is 1. We can find the last element by calling the index -1, similar to list, and this is ASBC. Okay, so this one is, yeah. Now, yeah. So basically, if you want to grab the element at the index -3, that is the third last element. So what is that? That is again 2, right? So this is the third last element. This is the last element, second last, and this is the third last. Okay. And yeah, so just 1 second. So I'll just expand this one. So yeah. Yeah. So one thing I wanted to mention to you, okay. So if I wanted to define, okay, so basically I'll just add some code cells below, and we just want to experiment with them. So suppose you wanted to create a list object which will have just one value, okay. So I'll just go ahead and print this my list, okay. So this is a list object. But what if you wanted to have a single element in your tuple? So I'll just create a tuple object which I'm naming my tuple, and I can just specify 1 comma here, right? Let's say if I want to specify 1, right? So I told you that when you want to create a tuple, we need to provide the element within the parenthesis. So let's go ahead and see if this works. Okay. So I'll just create this one. Okay. So I'll see what this is. Yeah. So this is 1. This is not returning with the parenthesis. Okay. So I should just go ahead and check the type of this object. Okay. So this is int. This is not a tuple. It was not happening with a list. In list, we followed the same convention, right? We needed to provide the elements within the square brackets, and yeah, we stored just one element. We did not have any other element, so we did not need to specify any comma here. And when we basically printed this list, it was giving us 1, and we can basically, yeah, just print the type of this as well, and this is a list. But what's happening in this case? Okay, so I'm trying to define a single element tuple in the same way, but this type is int. Okay, so if you want to define a single element tuple, you need to just add an extra 1 here. Okay, sorry, not extra 1, extra comma here. Okay, so if you want to define a single element tuple, okay, so basically you need to provide a comma here. Okay, so let's go ahead and see if this is a tuple. So yeah, this is a tuple. Okay, so remember this very important fact that if you want to define a single element tuple, you not only need to provide the parenthesis and the element inside it, but you also need to follow it by comma. Okay, and we can also define a tuple in another way. Okay, so especially, yeah, so we can, let's say, provide 1 comma. Okay, so if I just initialize this object, okay, and if I want to, let's say, type this, okay, so this is again a tuple. Okay, so you don't even need to specify the parenthesis. Python understands that if you have any element which is followed by comma, so that is a tuple. So let us see if 1 comma 2 is a tuple. Can we do this? Let's go ahead and see. Yeah, so this is again a tuple. Let's find out what is the length of this particular tuple. So this is 2. Okay, right? So this is again a tuple. Suppose I want to find out what is the first element of this tuple. Okay, so remember this is our tuple. Okay, so I just want to print out the first element. So this is 1, which is the first element, and what if I wanted to print the second element? So this is 2. So a very useful convention here, that we maybe it's up to us if you want to provide the parenthesis here. The usual convention is you provide the parenthesis, but even if you don't provide, and you just separate the elements by comma, okay, so that will be a tuple. Okay, so basically, yeah, you're asking about how do we create an empty tuple. So yeah, let's see what is this. So length is 0. Is this a tuple? This is a tuple. So yeah, so basically, yeah, you need to provide the parenthesis, and of course there will be no element within inside it. Okay, but if you want to have more or two elements, so I could have 1 2 3 4. This should be a tuple, right? What do you think? This is a tuple. I'll just go ahead and print the length of this my tuple. Okay, so yeah, so the length is 4. So depending upon you, either you can provide the parenthesis or you can choose not to. But yeah, it would be better if you provide the parenthesis. That is a standard convention, but you can choose to do that as well. Okay, so now next we talked of course about the indexing. Now next we talk about tuple slicing. This is very similar to what we did with list slicing. So of course we can use a colon to perform slicing, which grabs everything up to a designated point, right? The starting index is specified on the left of colon, and the ending index is specified on the right of the colon. Remember again, the element located at the right index is not included. So I have emphasized on this slicing method numerous times during the last 2 and 3 days. Okay, so you should remember this, right? How to take a particular slice of either a string or a list or a tuple. Okay, so all the same methods will follow. Okay, so let's see what we had in our another tuple object. So basically we had 4 elements in this tuple object. Okay, so the first element was 1, the second was 2, 4.53, and then ASBC, which is again a string. So if you want to take a slice, okay, so by slice I mean here I want to take starting from the second element till the third element. I don't want to include the fourth element, which corresponds to the index value 3. Okay, so this will just return me 2 elements. Of course, the index at element 1, index 1, and the element at index value 2. Okay, I hope this is pretty clear, right? And yeah, so if you again do not specify the ending index, then all elements are extracted which comes after the starting index, including the element at that starting index. We have gone through this fact over and over again. Okay, so the operation knows only to stop when it has run through the entire tuple. Okay, so suppose we don't provide anything to the right of the column, so it will grab the elements with all the indices after the index value 2, and of course the element at index value 2 will be included here, right? So everything, this will grab everything starting from the third element, right? So this 2 corresponds to the third element, right? So this is 4.3, this is the third element, and then ASBC. All right, again, if we do not specify the starting index, then all elements extracted which comes before the ending index, excluding the element at the specified ending index, right? So the operation again knows only to stop when it is extracted all the elements before the element at the ending index. So suppose I want to extract all the element before the ending, before the index 4, right? So basically I'll be getting 4 elements, and of course you know that our tuple has only 4 elements, so this will extract all the elements, right? So even if you provide 5 here, okay, so what this will give you? So this will not throw an error, but yeah, it's just even though there are only 4 elements, but you can just specify, yeah, just grab everything before the index value 5. So it will, yeah, just grab the whole tuple because the length of this tuple is 4 only, right? Then again, if you do not specify the either the starting index or the ending index, it will extract all the elements of the tuple. This is essentially the same as printing out your original tuple. Okay, so whether you provide the this or not, both operations are same, right? Now again, if you want to extract the last four elements, so yeah, just another example of slicing but with a negative indexing, right? So if you want to extract the last four elements, we can just do this. So the last four element is of course the whole tuple, because this tuple has only four elements, right? Now the same thing with which we encountered with list, that if your index exceeds the number of elements, essentially the number of elements minus one, then it will return an error. Okay, so basically if this is 4, do you think this will return an error? Of course, right? So the last element of course corresponds to 3, because the index value 3 corresponds to the fourth element. Okay, and there are no elements after that. Okay, so any value which exceeds the any index which exceeds the value of length of your tuple minus 1 will throw an error. And here again, this is the same index error, but here it's mentioning tuple index out of range, right? Because Python knows that this object is a tuple and we're trying to find an element using this indexing technique. So this is again an index error. We saw this with string, saw this with list, but this particular thing is changed. Python already knows that this is a tuple object. That's why this tuple index is out of range. Now again, we can use the length function just like a list. Okay, so so let's I'll just create another cell below. Okay, so let's create a random tuple. So basically so either 1, 5, 6, 2, right? So I'll add another code cell below. Let's see if sorted function works for a random tuple as well, right? We saw the sorted function to sort a particular list. Does this work with tuple? Yeah, so this also works with tuple. But what does this return? This returns a list. Remember, this returns a list. So suppose if I want to find the type of this particular object, okay, this is not returning a tuple, this is returning a list. So this is a list. Okay, so when you apply the sorted function on a tuple, so that will result in a list. Okay, keep this in mind. This is not a very major thing to understand, but the sorted function will return a list even if the object on which that sorted function is being applied on is a tuple. Okay, of course when we apply the sorted function on a list, it returns the list, but if we apply the sorted function on a tuple, it will return a list only. Okay, so just keep that in mind, right? Why is this the case? Because I told you that tuples and lists have very important distinction, that tuples object are immutable, right? So because tuples are also sequences of elements, and when I'm saying that they're immutable, that means we cannot interfere with the positioning of the elements as well, right? So a sorted function does not make sense for a tuple as well, right? Because then it will change the order of the elements in which the elements occur inside that tuple, right? So that will imply that the tuple object is immutable, is mutable, right? And that is the basic difference between a list and a tuple, that tuple is immutable. So that's why if you want to, if you are calling a sorted function on a tuple, this will return a list. Okay, so this will not return a tuple. Okay, so this is one of the manifestation of the property of a tuple, that tuples objects are immutable. Okay, we'll see a lot of methods which can operate on tuple, but none of these methods will change our tuples in any way, because those methods have not been defined for these objects. Because the basic premise for having these objects are to have such a sequence of elements with which you cannot interfere or which you cannot mutate, right? So these objects are very useful in certain contexts, which we'll see in next week. But so I'll just curb your curiosity for a little while. We'll get to know that. Okay, so let's discuss some tuple methods which we can which we have. Okay, so yeah, so one is your index method. So again, it is similar to an index method on a list. So basically I have a tuple here. Okay, so you can have similar, basically a lot of ones as well, so that you can have repeated element. But because this is a sequence of element, so Python knows that this one is different from this one because its index is different from this one, right? So for example, in your name you can have two letters in your name, right? Okay, so for example, Akshay. Okay, so it has two A's, but both the A's occur at different positions in your name, right? So there is difference in both the A's. Okay, but because of the property that they're occurring at different positions. So that's why this concept of sequence is very important. And tuple is essentially a sequence of elements, but of course the sequence of elements cannot be tampered with. Okay, but we can apply an index method to just find out the index of a particular element, as we did with list. So in the index, how do we call the index method? So we write the tuple object here, then write dot, and then write the method name, okay, which is the index, and within the parenthesis we provide the argument. So what is the argument here? The element whose index we want to obtain in that tuple, right? So I want to find out that what is the index of this element 4. Okay, so this will return 3, right? So this is sitting at the index value 3, right? So this is the fourth element. Of course the value is also 4 by coincidence, right? Don't confuse between that. And suppose I want to find out the index of the element 2. So I have two 2's here, right? So what is this? This is 1. So this will of course return the index of the first occurrence of a specified element, right? This must be clear to you from the last class, right? Yeah, so there is no concept of a sorted tuple. Okay, so basically we'll see that why that should not be the case, right? Because see, tuples have been defined as such objects which cannot be changed, that they cannot be mutated, right? So that's why there's no concept of sorting a tuple. Okay, because then it will change the order of the elements in which occurs inside that tuple. If you want to apply some basically we want to have some sorting capability, so you will need to store those elements in a list. Okay, so list objects would be a nice thing to have when you want to interfere or change the position of the elements, do a lot of operations which will change your elements. So a list is a very good option in that case, but there is no so the concept of sorting does not it does not make sense here. Okay, so I hope that's clear. So now, yeah, so basically, yeah, we can use the index method, and next we can use the count method. So count method, what it will do, it will return the total occurrence of a specified element in a tuple. So basically, yeah, so the count method is, again, it takes the element whose count we want to get, right? Okay, so basically one occurs a lot of times here. So let's just go ahead and run this one. So we'll see that one occurs 3 times in our tuple. What about 2? Yeah, it occurs 2 times. Okay, here and here. Okay, so yeah. Now, again, we have been talking a lot about this property of immutability of a tuple. It can be stressed enough that tuples are immutable, right? So my tuple, the first element of my tuple is 1, and suppose if I want to assign this particular element with another value, right? Can we do this assignment operation? We cannot do this, right? In list we saw that we can do this, right? Yeah, in the assignment here we saw that if you wanted to swap, right? So here we were able to do this because lists object are mutable, but tuples are not mutable, so we do not have this uh, freedom to make changes to our tuple. Okay, So it will just return the type error that tuple object does not support item assignment. This is similar to strings, right? So in strings also they're immutable. Okay, and we found that, yeah, means basically you cannot interfere with the list. Okay, and yeah, so that is the case. Okay, so because of this very important property of immutability, tuples can't grow. Okay, so once a tuple is made, we cannot add to it, right? So immutable, you should understand what I mean by immutability, right? So immutability is the property of anything. uh, Basically it has so much inertia that it cannot be changed, right? Neither the shape nor the size. Okay, so here also the idea of basically having a tuple is to have some object which we have, once we have defined that object, we cannot alter that object. Okay, so you cannot remove any element from a tuple, you cannot add any element to a tuple. Okay, so whatever list methods which we encountered earlier, so basically we are seeing that there was an extend method, there was an append method. So those methods will not make sense for a tuple, right? So because the basic definition of those methods was to add certain elements in your list, right? But because by the very definition of a tuple that these are immutable, so those methods do not make sense, and hence they have not been defined for a tuple. Okay, so yeah, so tuple does not support methods such as append, extend, remove, or pop. So I'll just yeah, just give you a basic example of this. So see, I wanted to append this element no, and it's saying that the tuple object has no attribute append. Also, one cool thing in what you can do, that basically see, when you write a tuple object, this my tuple is a tuple, right? So when you write dot, so Python automatically shows you the methods associated with it, right? So it only shows you count and index. So there are only two methods which are associated with tuple, that is count and index, right? So basically see, if we have a list here, okay, so if I do the same thing here, so it will yeah, display all the methods which are available with a list object, that is append, there is clear, there is copy, count, extend, index, insert, pop, remove, reverse, sort, etc. Okay, yeah, so basically yeah, so the tuple object only has two methods associated with it, that is one is count, another is index. Okay, so the index method returns the index of any element, and the count method returns the count, or the total number of occurrences of that element inside your tuple. There is one important basically function. Okay, what it does, that it takes multiple lists as an argument, which this function is zip, and it zips them together. So what is the meaning of zipping? So basically this method returns a list of n paired tuples where n is the number of lists being zipped. So I'll just see a basic example of this. So suppose you have two lists here, a city list, okay, and you have a river list, right? So basically so you want to zip them together. What is the meaning of zipping here? So basically zip this one is with this one, zip this one with this one, then this one with this one. And so basically we want to have certain pairs of city and river. So Delhi corresponds to the river Yamuna, Patna corresponds to the river Ganga, then Cuttack corresponds to the river Mahanadi, and then finally the city Guwahati corresponds to the river Brahmaputra. So we want to zip them together. So basically element by element, we want to zip them together. So what we can do, basically we can call the zip function here, and it will take the list as its argument. So here we just want to zip two lists. So we'll provide the list here. that is the city list and the river list, and zip them. Okay, and basically I am just calling another list over it. So what this will return, I'll just show you. Sorry, I have not already run this one. Okay, so yeah, now I can, yeah, just print this one. So basically, yeah, it zipped the elements together. So basically now every element of my final object is a tuple. Okay, so every object is a tuple in which the first element comes from the city list, and the second element of this tuple comes from the river list, and correspondingly we can basically have, right, so we can have, yeah. So basically, yeah, so just yeah, let's see what this returns. Okay, so let's just print this one. Okay, so this returns something like a, this is a so this is some instance. Okay, so we do not need to focus on this one, we'll be diving this in later, but we can basically, this is sort of a generator object on which we can apply a list function. So just to avoid any confusion, so that's why I applied the list function here. So basically when you are zipping two lists together, okay, you apply the list function on top of that. So this is just for demonstration, this is not a major thing you should know. Okay, of course you'll know about this later on, this will be very useful, but just to keep in mind that when you are applying the zip function here. Okay, so yeah, you can see the definition here, that returns a zip object whose next method returns a tuple where the ith element comes from the ith iterable argument. So in this way, in this case, the first element of my, so this tuple, so the first element comes from this list, that is the city list, the second element comes from the river list. So just keep in mind, this is not a very important concept at this point of time, but we'll have a lot of time later on to come back to these important functions. So we'll be using them later on, but for now, just keep in mind that we have such methods at our disposition. Okay. So yeah, so a final comment on tuples. So maybe when you want to use tuples, so you may be wondering why bother using tuples when they have very fewer available methods. In fact, this is one of the properties which you actually want in some objects, because see, later on when we'll discussing Python functions, so maybe we'll have to pass around some objects. Okay, and we'll need to make sure that that object which we are returning or just passing around, it does not get. So yeah, sorry for the inconvenience. Yeah, it got disconnected. But yes, we're talking about tuples. So tuples will be very important when we discuss functions later on. So just keep that in mind. Right? We need to have we do need to have some objects over which we have less control. As in, basically, we cannot manipulate with them a lot. Okay, so tuple is one such object, and it would, you'd realize later that it is nice to have certain objects in our basically later on. Okay, next we talk about another object. So we talked about a lot about tuples. Now another very important object in Python is a set. So I think you would be familiar with the term set. You might have read about sets in your class 11th set theory. So basically, what is a set? A set is an unordered collection of unique elements. Okay. So we can construct a set by using the set function. Okay. Sets cannot have duplicates. Right. This is a very important object property. So yeah. Just And yeah, so the another property of a set is basically sets are mutable just like lists. So sets are mutable, means they can be changed just like we saw with list. And one important property is that sets cannot have duplicates, okay, which I already told you. And you can create a non-empty set with curly braces by specifying elements separated by a comma. Okay, so unordered means basically means the ordering of the elements does not matter. Okay, so basically, yeah, there is no concept of as an index. Okay, so ordering is not so set is not a sequence of elements arranged in a way, but this is just an unordered collection. Okay, so it is just a so consider this as a bag which is full of some stuff, right? And yeah, so that is it. So all the elements inside that bag should be unique elements, and it will just be a collection of those things. Okay, so yeah, that is what I mean by unordered. So how do you first let us see how you create an empty set. So basically, yeah, you write a variable name empty set here. You can write anything you want, and we use the set function here. Okay, and we provide nothing here. So this will create an empty set. Yeah. So basically, we can print print this, and this will give me an empty set. What about if I want to create a non-empty set? So in this case, we have to provide the elements within the curly braces, and they will be separated by commas. So remember, in list we had the square brackets. In tuples we had parenthesis. Okay, and in a set we'll have curly braces. Okay, and all the elements are separated by commas as are in a list or in a tuple. Okay, so this is just another way to define a set. Okay, so I'll just go ahead and execute this particular cell. Okay, so this is a non-empty set. Okay, so basically, see, the ordering does not matter. So it is just giving some elements in a particular sequence. Okay, so even if I write 7 here, okay, so it will just return a set here, right? So basically, by unordered, I mean that the idea of index, basically the idea of position of an element does not make sense for a set. Okay, so it's what is it? So it is, suppose it is just a collection of these elements. Okay, it does not know what is the position of these elements, because this is not defined as a sequence of elements. Okay, so a set is just defined as a collection of elements. Okay, so just like I gave you the analogy of a bag full of some items. Okay, so basically it just have those items, but there is no way to figure out which item is placed where. Okay, so it's any item could be anywhere. Okay, so I hope that is clear. So yeah, so basically, suppose if you want to have basically an integer with a string, can we have that? Yeah, I think, yeah, we can have that. So also, if you want to find out the type, so these things are common for basically your tuple, your list or a set. We can have elements of multiple data types. Okay, and yeah, so that is the idea. So you can have different data types in a set. Okay, nobody is asking you to means just put your numbers in your bag, but you can put a string, your means even a boolean. You can do anything if you want to fill your bag. That means filling your bag, that is providing the elements within the curly braces, and the elements of course will be separated by comma. Just remember that the concept of index does not apply to an empty set, right? So there's no ordering, there's no concept of sequence. So this particular thing you should keep in mind, right? And yeah, so one important thing that when we wanted to we are creating a non-empty set within the curly braces, then you would natural question you would ask that why not use the empty curly braces here for defining the empty set? Why do you use this particular set function? So we'll just find that out just in a while, that this particular thing, that empty curly braces is reserved for an empty dictionary. So dictionary, will be learning about dictionaries today. So that is reserved for that. So yeah, just don't worry about it. Okay. So if you want to define an empty set, you have to call this set function. Okay. And within the parentheses, you don't have to define. Okay. So this is essentially a null set. Okay. So you remember that we define, means basically in your set theory, we define a null set as 5. So that is, yeah, essentially your set here. It's similar, right? Now, yeah. So basically, if you wanted to just check, can we, yeah, means why can't we do that? Means basically just provide the curly braces. So let's see what is the type of this particular object. Okay. So this is a dict, which is short for dictionary. Okay. So yeah, you cannot use the curly braces, empty curly braces, to define your empty set. Okay. So just remember, keep that in mind. Okay. Of course, we have to use the set function. And yeah, so basically one important thing you learned about set, that it is a the ordering does not matter. Okay, so it's unordered. And there's also that it is a collection of unique elements. Okay, so what is it? So basically I have created a list in which I have a bunch of ones and I have a bunch of twos. Okay, so I just create this list and apply the set function on my list. And yeah, so I'll just basically run this one, and what do I get? So I get the set. Okay, so I get a set which is so the ordering does not of course matter, and all the elements are unique here. Okay, so there's one interesting question we are getting. So I'll just run this, because these are just experiments which you so for example, I define a variable my set, and if I want to, let's say, use the set function to create these elements, can we do that? Yeah, we cannot do that. So it is not a way to define a set, means basically a set, right? So we need to provide the curly braces. Okay, we need to provide the curly braces. So a set function can it can take at most one argument. Okay, so this will be your set, but of course you cannot define a set in that way. Okay, so these are basic experiments which you can do on your own as well. Okay, so right, so you have a whole playground to just play around with these ideas. These are very definite very good ideas, and yeah, you should have this curiosity to kind of figure out things in a bit different way, right? And yeah, so just moving ahead, so basically one thing is, as I told you, a set cannot have mutable items. Okay, so the thing is, basically I told you a set itself is mutable, but a set cannot have mutable items. So for example, a list is a mutable element, right? And it cannot be a part of a set. Okay, so I'll just go ahead and try to declare this particular statement. So it's saying that type error, unhashable type list. Okay, so we cannot have mutable items. What about a tuple? A tuple is not mutable, right? Can we create a tuple here? Let's go ahead and see. Right, so I'll just keep the square brackets here. Yeah, but we have it here, right? So if I want to define a set in which I have a tuple element, so that can be part of a set, right? So see, this element comes at first, then yeah, so this ordering of course does not matter. It's just a way in which when we print out our set, it displays in that particular fashion. Okay, but of course there is no concept of ordering, and your set element cannot have basically elements which are mutable. So can we have a set inside a set? So we can have a basically a tuple, but I told you that a set itself is mutable. Can we have that? Yeah, so basically I'll just define my set is equal to 1 2 and then basically 3 5. Okay, and so I'll add another code cell below. So can we have that? So again, it's saying that type error unhashable type set. That means a set cannot have any element which is mutable, right? Right. So basically, yeah. So just keep this in mind. Even though set itself is mutable, that means you can remove these elements, or means you can kind of add certain elements. But the elements within a set, those should be of immutable nature. Okay. So the elements with inside your set, they cannot be mutable. Okay. The set, the overall set is mutable, but the elements within the set, they are not supposed to be mutable. Okay, otherwise you'll have errors basically when you're trying to just do that. Okay, so now let's go through some common methods which are available in with the set objects. So one is your add. So what does add do? So basically, if you want to add an element to your set, so you can do this. So I have an empty set. You remember from earlier, empty set is your null set. So we can add an element to that, and let's just print this. Okay, so you can see that your set is basically within the curly braces, and there is one element. We can add another element there. Okay, and sorry, x is not defined. So of course, empty set. Yeah, so I'll not call this empty set. Yeah, I'll just call it my set, and yeah, basically I'll yeah. So this is my empty set. Of course, when you're adding element, your empty set means basically that name nomenclature is not correct. Okay, so your my set now has one element, and I want to add another element to my set. Okay, yeah, sorry, not this one. Yeah, so I can just use the print function. So yeah, so basically 2 and a, right? So these are the elements. So you can similarly add another element. So add is a method which takes any element which we want to add to the set, and this will return the updated set, right? So this means that your set is mutable, right? Your set will be changed when you apply the add method, right? So keep that in mind, right? So you can add as many elements as you want. Okay, then there is another update method. So suppose you want to add, so earlier using the add, we are just able to add one element, but suppose we want to add a lot of other elements as well. Okay, so just consider a very nice example here. So here in my set, I have 4 elements, 5 7 9 3, and I'm using the update method. So update will take a list of elements which we want to add. Remember, this is a list of elements. Okay, this update will take a list of elements. Okay, and see, 3 is already part of our set, so it will just ignore that one. So when I just basically print this, so I just have, of course, this is a collection of unique elements, so there will, of course, will be 1 3, and 2 was not there, 4 was not there, but now it's part of that set. Okay, then we can use another method which is called remove, which you are already familiar with. So we can remove a particular item or element from the set. Of course, there is no concept of index. So and also the remove method takes the argument as the element which we want to remove. So basically, I want to remove this element 5. Okay, so I'll just remove this. Okay, so by calling the remove method, and I'll just print this set. So of course, this changes my original set, which is now I just have 1 2 6 7 3. Okay, so yeah, just keep this in mind. Okay, so there is no concept of index in set. Okay, so you can, and what happens if you want to remove a particular element which is not part of this set. Okay, so suppose I want to remove 45. This is of course not part of this set. So what this will yield, yeah, so yeah, this will return an error. Okay, so basically it cannot remove this element because this element is of course not part of your set, right? So remove throws an error when we try to remove an element which is not present in the set. Okay, then again we have union. So from your set theory, I guess you would remember a little bit that we can have union of two sets, right? So what is a union? So basically I have two sets here, right? So the first set contains the element 1, 2, 3, 4, 5. The another contains 4, 5, 6, 7, 8. We have two common elements here, right? 4 and 5. So we'll see what the union will return. So there's two way to get the union. First is basically on your first set object, you just call the union method, and the parenthesis you provide the another set with which you want to unionize, right? So I'll just print this. So yeah, so this will have of course unique elements. Okay, so this is the union of two sets, right? The same result you can get by basically using this operator which is pipe. Okay, so this is basically, yeah, A or B, right? So this is A or B. So basically any element which is in A and any means all those elements which are in A or all the elements which are in B. So basically all the elements from the two sets here, right? Then another method which is your intersection. So intersection basically method returns the intersection of two sets. So I have the same sets here. Okay. So what does intersection will give me? So from your set theory, you'd remember that it will give me the common elements of the two sets. So you see that 4 and 5 are the common elements in these two sets, and that will return here, be returned here, right? Using the intersection method. So this is the same. How do you apply this method? So you write your first set object followed by dot. You write the method name here. So methods are more or less applied in this fashion, that you have an object on which we can, yeah, apply that method. So followed by dot, and within the argument you will have the another set with which you want to find the intersection with, right? We can also do the same operation by the operator and. Okay, so A and B. So basically all those elements which are common in A and B. Okay, so 4 and 5 again, right? Now there is another method which is the difference. So what does the difference method returns? So it returns the difference of two sets. Okay, so difference of the set B from set A, that is A minus B, is a set of elements that are only in A but not in B. Okay, so this is very important definition. So I'll just tell you. So basically you see that only yeah, so these elements are yeah, so basically the difference will be the set of elements which are only in A but not in B. So because we have two common elements here. Okay, so what will the difference A dot difference be return? It will return 1, 2, 3. But yeah, we can do the same operation by doing A minus B. So A minus B will also return me only those elements in A which are not in B. What about if I do B dot difference A? Now the order is different. Okay, so this should give me all the elements which are in B but not in A. Okay, so what elements are in B but not in A? Okay, means basically which are only in A but not in B, right? So 6, 7, 8, right? 4 and 5 are already in basically A, right? So this will not be returned, right? I think, yeah, this is pretty straightforward. Again, you can, yeah, so I'll just add another code cell and I'll write, yeah, B minus A. It will just return the same thing. Yeah, so all those elements which are present in B but not in A. Now we have another important last method, which is the symmetric difference. So what is the symmetric difference return? So this method returns the set of elements in A and B but not in both, excluding the intersection. Okay, so basically these are the two common elements in our sets, right? 4 and 5. So this will return all those elements which are not both in A and B. So basically 1, 2, 3, 6, 7, 8. So let's just see that. Yeah, so this is the symmetric difference. Yeah, and yeah, so another operator for this is a uh, basically power b. Okay, so this will return the symmetric difference. Okay, so you can go through these functions. So you can go through these functions as we move ahead. Okay. Yeah. So now, yeah, we're coming to the last topic. So yeah, so the final topic for today is dictionaries. So we have been learning a lot about sequences in Python. So we saw three type of objects which are sort of sequences. The one is your string, the other is your list, and the third one was tuple. And set is not, of course, a sequence. It's a sequence means you should have ordered elements. There is a concept of index associated with a sequence, but because set is just a bunch of collection. So we have been learning a lot about sequences in Python, but now we are going to switch gears, okay, and learn about mappings in Python. So this is one of a very important object in Python, and you will be using this a lot. Okay, so what are mappings? So mappings are a collection of objects that are stored by a key, unlike a sequence that stored object by their relative position, that is by their indexes. Okay, so this is an important distinction, since mappings won't retain order since they have objects defined by a key. So we'll see what does this mean. Okay, and a Python dictionary consists of a key and then an associated value. That value can be almost any Python object. So a dictionary object always has elements as key value pairs. So here we are kind of dealing with mapping. So we don't have the concept of ordering, but we want to know which element is which, right? So this is very important. So a dictionary object is constructed using curly braces. Okay, so this is constructed using curly braces. And how do you, what does a single element in dictionary looks like? So basically you have a key and there is a value corresponding to that key. Okay, and this will be separated by a colon. So this is one element and the another element will be separated by comma. So all the elements in a dictionary will be separated by comma, but the important thing is it's a key value pair. Okay, so there is a key and there is a value corresponding to that key. So let's just see what does this mean. Okay, so I have a marble deck. Okay, so basically a dictionary. So I have a key name. Okay, this is of course a string, and the value associated with this key is Thor. Okay, and then I have another element. So this one. So this is one element. Okay, this one is one element because any element of a dictionary is a key value pair. So there are two basically two numbers, that is a pair of numbers. So the first will correspond to the key, the second will correspond to the value corresponding to that key. Okay, that is how we'll reference any element. So we'll have the key to get their values. So in list also, if we wanted to get an element, we can find that element by using the indexes. But here we don't have the indexes. Okay, so basically we can reference to any value using the key for that value, right? So there is another element which is again a key value pair. So the key is place and the value is Asgard. So basically I am kind of in a dictionary, I'm storing a bit of information about a Marvel character Thor, right? So the first element contains the information that, yeah, so then there is a key name which contains the value Thor. Then there is a key place which contains the value Asgard. Then there is a key weapon which contains the value hammer, right? So this is again, this is the third element. So this dictionary has how many elements? Three elements, right? So basically, yeah. So if you want to find out any particular value, so we have to call values by their key. So what we can do, so because we don't have indexes here, so we'll use the usual square brackets to get a particular value. So I call the dictionary object, and within the square bracket, I cannot specify the index because of course there's no concept of index in a dictionary, but we can write the key for which we want the value. So let's go ahead and run this one. Yeah, so what does this, of course I have not defined this, right? So basically, yeah, I'll come back to that question. So can a key have multiple values? So we'll see about that. And so yeah, I'll just try to find the value corresponding to this key, right? So this is the key, sorry, this is the key, and the value corresponding to this key is Asgard, right? So this is the key, and how do we get the value for this key? By doing this operation. So basically I am calling the dictionary object, and within the square brackets I am specifying the key here. Okay, now what if I want to get the value corresponding to the key name, right? So remember that a dictionary is a basically a collection of elements, and each element is a key value pair. So we can always find out, basically refer to any value, but we have to refer to that value using the key. Unlike in list, we are referring to any value using the indices, right? So suppose I want to find out what is the value corresponding to the hammer. So we can just write, yeah. So Marvel Dick, yeah. And remember that, yeah, in Colab, it gives you suggestion if any object has been created from earlier, right? So it's sort of, yeah, you can just select that. Yeah. So basically I provide the value key. So this is weapon. Okay. Okay. So, but we can not only have any only strings here. We can have key as basically numbers. Okay, and the value can also be number or any string. Okay, so suppose I have one key which is basically an integer, and the value to that basically corresponding to that key is an integer. We can have a key which is an integer, but we can have something like means basically the corresponding value could be a string as well. So basically, yeah, just let's go ahead and define this. And now we can, yeah, means basically see what is the value corresponding to the key 1. Okay, so it can have, so this is 2, right? What is the key corresponding to the value 3? Means basically what is the value corresponding to the key 3? So the key will always comes first, and there is a colon between your key and value. So always keep this in mind. In a dictionary, you will always have a key value pair, and basically those will be separated by a colon. So that means 3 maps to power. Okay, so I'll just write the key here, and this should return me power. This returns me power. Okay, so if I want to refer to any value here, I can just basically within the square bracket I can specify the key. Okay, so a key in a dictionary corresponds to a particular value in that dictionary. Okay, so you can have any type of elements within a dictionary, as I told you here. Okay, so basically that value can be almost any Python object. Okay, right? So you can have in fact a list as well. So I'll just suppose I have let's say uh, basically alibis. Okay, so this could be your Miss Iron Man, right? So Iron Man, you could have Captain America, right? So this is a list. So basically there is a key, and the value corresponding to this key is a list. Okay, so I'll just, yeah, redefine this dictionary, and basically I want to find out what is the value in it corresponding to the key alibis. So this will be, yeah, Iron Man and Captain America. Of course there are more, but this is just for demonstration that the value corresponding to a key can be means any object. It can be a dictionary itself, right? So let's yeah, means just we can see there's just another example. I'll just create another ABC, and we can have a dictionary within it as well. So I can have a dictionary, for example, 1 is 2, and then let's say 4 to 5, right? So what is the basically, yeah, what is the value corresponding to this key? So this is a dictionary itself, right? So this is a dictionary only, right? You can find the type by calling the type function here. So this is a dict, right? So basically, if you want to refer to any value, you will have to yeah, provide the key. Okay. So 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 basically, this is any element in a dictionary is a key value pair. So we'll look at different methods, and can we basically get a key corresponding to a value, or can we do other stuff? So we'll see. Okay, so there is one keys method. So keys method returns the list of keys. Okay, it returns the list of keys in the dictionary object. Okay, so I'll just use the marble dict which I've already created here. Okay, and so if I call the keys method here, what this will return me? So this will return me the list of keys. So what are the list? It will return me a list. So this is a name. So yeah, we'll just go back to the dictionary. So what are the keys? Name, place, weapon, 1, 3, alibis, and ABC. So these are our keys. Okay, so name, place, weapon, 1, 3, alibis, ABC. So these are our keys. And so here you are getting dict keys. So you can basically convert this to a proper list by just calling the list function. Okay. So just call this and this will return you a list of keys properly. Okay. So there is no dict keys here. Okay. So basically when you want to have a list of basically return the list of keys. So just write the list function, and within the list function provide basically uh, marble dict dot keys. Okay, so again, if you want to get there's another dictionary method, that is values. So this returns the list of values in the dictionary object. So again, I'll just write the marble. So basically, yeah, it suggests me marble dict. Yeah, so yeah, so again, I'll just use the list function to get a proper list here. Don't worry about what is this dict values for now. That will become clear. So yeah, you just should not worry about that. See, so what are the list of values which you have in dictionary? So you remember, I'll just one second. Yeah. So basically, I'll just yeah move this up, and so I'll just print my marble dict from earlier. So yeah, so what are the values we have? Thor, Asgard, hammer. Okay, so anything which appears to the right of the colon, that is the value, and anything which appears to the left of the colon, that is the key. Okay, so yeah, so basically, what are the values? So Thor, Asgard, hammer. Then we have two. Then we have power, right? Then we have this list, right? Which is again a particular element, and then we have this dictionary object as well, which is again a particular element. So if I print list of marble dict dot values, so this will return the list of values. So basically Thor, Asgard, hammer, 2, power, then the list, Iron Man, Captain America, and then the dictionary. Okay, so yeah, so this method, that dot values method, returns the list of keys, and by hovering over, you'll basically, yeah, so built-in method values of dict object. Okay, now items. So this is another very important method. So what does this return? So items method returns the list of the keys and values. Okay, so I'll again call the, because this is returning the list, so I'll just apply the list here. You don't worry about dict items here. We'll yeah discuss about this later on. So sorry, not employee dict. We have not defined that, but we have marble dict, and we'll yeah continue with that only. Yeah, so basically this is giving me a list of tuple. So what is, so the first element is my key, and the second element is my value for that key, right? So marble dict dot items, it returns both the keys and the values, okay? And so this thing returns the list of the items present in our uh, dictionary. And how does it return the item? So each item is now a tuple, okay? So where basically the first element is the key and the second element is the value corresponding to that key, okay? So this items method returns the list of keys and values, okay? So the place was another key and the value corresponding to that was Asgard, okay? So similarly we have all these key value pairs. So yeah, so hopefully this is clear, okay? And yeah, so basically we can also use the get method to extract a particular value of key value pair, okay? So suppose I want to find out what is the value corresponding to this key, right? So I can use the dot get method and mention name here. So this will return me Thor, right? So if I have a place here, right? So so we'll get extract a particular value from that key value pair, okay? So the get method takes key as an argument, okay? It takes the key as an argument and returns none if the key is not found in the dictionary, okay? So basically, yeah. So I'll yeah. So yeah. So suppose there was no key as so the key here is girlfriend. I'll just change this to a friend, okay? And I'll do the corresponding change here as well. So yeah. So basically marble dict dot get friend. So friend is not a key in our marble dict, right? So this will return none, okay? And yeah, so basically you can provide a second argument for this get method in which if this key is not present in your marble dict, so basically you can set what to print. So for example, if this key is not present, this will return the value not found, okay? Yeah, so here if when I'm just calling the get method with the key which I want to look for, means basically I want using the get method I will get a value for that key, right? But if this key is not present, okay, so if this key is not present, it will not return anything, but we can customize what we want to print, okay? So this will print not found, okay, here. But the thing is, there's another way, means the earlier way when we were basically calling, wanted to get a value corresponding to key. So we're using the square bracket, and within the square brackets, I was mentioning writing the key. So this will return an error. Okay, so key error friend. So this is no, so this will just return a key error. So to avoid this error, that's why the get method will be helpful. Okay, so it just returns none. None is basically not any object. Means yeah, it's a null object. So get method is powerful when, let's say, if you're looking for a key in your dictionary and it just returns an error because it could not find any such key in your marble dict. But the get method sort of helps us get us around this error, and this returns none. And we can also set in the second argument of this method what to print if we are not able to find this. So suppose we have this place, right? So this will just return the Asgard. So this is not returning or not found because this place is already a key in our marble dict, right? Now, yeah. So it is important to note that dictionaries are very flexible in the data types they can hold. For example, employed. So I am just providing another, yeah, dictionary. I am defining another dictionary in which I have a bunch of key value pairs. Okay. So yeah. So basically, the first key is name, and the value corresponding is Sanket. Then we have another key skills, and the value corresponding to that key is a list, which is the set of list of skills, that is Python, machine learning, deep learning. Then there is a band key. The corresponding band for is that 6.0. It is some level. in your basically organizational hierarchy. And this is a promotion here, which is again the value corresponding to this key is yeah, a list object. Okay, so basically let's say you wanted to find out how many basically what is the size of your dictionary. So what you can do, you can simply write employee dict dot keys, right? So the number of, oh sorry, an employee dict has not been defined here. Yeah, so this is 4. So there are 4 elements, right? So this is one element, right? Then there is the second element is this one, right? Then the third element is this one, right? So every element is a key value pair separated by colon. Okay, so you can find the same length because there is always a value associated with a key, right? So this will also be 4. Yeah, it's taking a bit to print. Yeah, so 4. So we can just call items from the dictionary. So yeah, if I provide the key skills, it will return the value corresponding to this key, that is this particular list, right? Then so basically this is a list. So this value is a list, right? So now because we have a list, we can do indexing, right? So I want to get the first element of our dictionary object. Okay, so we want to have a get the first element of our basically the value which corresponds to the skills. So this is a list, right? And by using the indexing operation here, so this will print basically get the first element, which is Python. And because this is a string, so so just keep in mind this whole thing is a string now, right? I'll just repeat this again. So this is a list. Now we applied the indexing operation after that. So this is the first element of this list. Now this, because this is a string, so we can call a string method. So you're familiar with the upper method, which converts all the characters or the elements of that string to upper cases. So yeah, we can run this. So this will convert everything to upper cases, right? So now we can basically add another key using a particular method. Okay, so not a method basically, but if you want to add another key value pair, so what we can do, so see, in our employee dict we just have 4 elements, right? So there are 4 set of keys: name, skills, band, and promotion here. I want to create another element with a key value pair. So can I do that? So yes. So dictionary objects are also mutable. So how we can do that? So basically you write the key here which you want to create in your dictionary and the corresponding value. So basically the key I have designation and the corresponding value is senior data scientist. So I'll just go ahead and run this. Okay, and I'll just print this employee dict again. So this is so designation is, so you can see the keys here are ordered in alphabetical order, but that is immaterial because whatever values we want to refer to, we have a corresponding key to that. So this is sort of a replacement for having an index in which only made sense when we had a sequence of elements, right? So but in dictionary it's not a sequence, but essentially it's a mapping. So there is a key value pair which tells me that a particular value is mapped to a particular key. Okay, so now I have basically added one element to my employee dict. So you can add as many elements as you want. Okay, so now I can add an element which is a key value pair using the update method. Okay, so here there was one way in which I can add one element to our employee dict, but there is another way in which we can basically add such an element. So basically what update method does, so you can add an element which is a key value pair, and this method takes a dictionary as an argument. So basically the dictionary of the element which you want to add. So the element in the case of dictionary is a key value pair. So what that element will be? So it will be, so because this is a dictionary, so which we want to add using the update method, and because the argument of the update method is a dictionary only, so we can provide the key value pair within the curly braces, and of course these will be separated by colon. So this is one dictionary, right? So dictionary consisting of one element, and we can apply the update method here. Yeah, and we can see that, yeah, the salary is basically 2 million here, right? So salary, I've also added another key. So as you can see that dictionaries are very useful way to store information. So all these things, it sort of tells you about a particular person, right? So there is a person whose name is Sanket, right? What is his designation? Then what were his promotion years? Then what is his salary? What are his skills? Okay, what is his band? So this provides a very good way to sort of store your information, right? Which will be very useful later on, as we means basically deal with deal with dictionaries later on. So we'll see that such type of storage of information, or such way of representing your information or storing your information is pretty powerful. Okay, and yeah, so basically, yeah, you can update another. So you can basically use the update method to update the existing values for a key. So I have the name as Sanket here. Can I update the value for this key? So I can use the update method. So update method not only helps you add any element, but helps us to update the existing values for an existing key. So I'll just run this particular cell. So we already had this key earlier in our dictionary, and we can update the name of our basically, sorry, value for this corresponding key. And let us see if that has been updated. So the name has now been updated from Sanket to Varun Sani. Okay. So in this way, yeah, we can use the update method. So update method can be used to add any new element, or basically update the existing values of an existing key, right? So we can also affect the values of a key as well without the update method. Okay. So if you're not using the update method, we can update the values. So earlier we saw that if we wanted to add any new element, we use this particular thing in which we added a new key and a corresponding value to that key. We can add a new element basically, or basically update any element. So we can do anything with the value of that element basically. So name is the key, and we want to update the value corresponding to that key, which is name here, right? So I'll write employee dict name plus uh, uh, this space, then Raj. Okay, so I'll just do this. Okay, so in this way I am sort of updating the value corresponding to this, and this is an existing key, right? So yeah, so this is employee dict. So now you can see that the name Varun Sani has now been updated with an extra addition of a space plus Raj, which is what I did from here. So you can update the existing values corresponding to a key in a dictionary by two ways, either by this method, or basically by using the update method. Okay, so it's upon you. Okay, now there is a dict method, so we can also create dictionary objects from sequence of items which are pairs. So this is done using the dict method. So what does the dict method take? So it takes the list of paired elements as argument. So basically, so I have a list of tuples. Okay, so what does this list of tuple have? So yeah, basically, yeah. So we have a list of tuples, that is a country city tuple. So basically this pair is what, the country and the capital. Okay, so this is a list of tuple in which the first element of each tuple element is the country and the corresponding capital of that. Okay, so let's go ahead and create this list of tuples. Okay, so a list can have any type of elements, right? It can be any data type. So a list can have a list inside it. It can have even dictionaries. It can have tuples. So in this way means I am having a list of tuples. Okay, so every element of this list is a tuple, and this is a paired tuple. That means there are two values for each tuple, right? So now using the dict method, basically. Uh, yeah, we can create a dictionary. So what will this yield us? So yeah, we can basically have the country as the key and the capital as the value corresponding to that key. So dict method helps us to convert a list of tuples into a dictionary. Okay, so dict method does that. So the first element will be the key, and the second element of that tuple will be the value corresponding to that key. We are running out of time now, so we won't be able to take doubts today. So if you have any further doubt, so basically, yeah, you can write your doubts in the discussion forum. We'll try to answer them. So basically, yeah, just wanted to discuss the last method, and then we'll have a final quiz. So the last method is pop. So pop method removes and returns an element from a dictionary having the given key. Okay, so this method takes two arguments or parameters: key which is to be searched for removal, default value which is to be returned when the key is not in the dictionary. Okay, so basically in this the country city dict, I want to remove this element. This is England, London. Okay, so I'll just use the pop method, and what this will return, this will, so I'm storing this in an element, but of course because I've applied the pop method, so this has changed my original dict as well. Okay, so yeah, so England is not a means the basically the element in which the England was the key has been removed from the dictionary, right?